everybody. I've been looking at COBOL again, looking at an advent of code here. It's one I've done before at some stage. And I was looking at this thinking, this is a nice one to do in COBOL. I like writing COBOL code because I think it's fun. It can be quite challenging at times, but it's fun. And it allows me to concentrate on what makes code readable, what makes code not readable, things like that. Makes me realise how important naming is, and how important it is to name functions which make it clear what sort of effect they have on the world. So you can use your intuition rather than having to read every single function. The basic idea of this advent of code is to find the total number of numbers between that and that which fulfill these conditions. And there are some examples. So you can see that's the first half, and the answer was 1169 apparently. And for the second half, the conditions are slightly different, and the answer was 757. Okay, but the conditions are fairly simple as well. So it's a value within the range given in your puzzle input, so from the first number to the second. Two adjacent digits have to be the same, like 1, 2, 2, 3, 4, 5. And the digits can never decrease, so they go upwards all the time, or they stay the same. So that one is not valid, it does not contain a double. That one is valid, it contains a double 11, lots of them, but it contains at least one. That one is not valid, 0 is smaller than 5. Okay, good. That's basically the first half. Let's get this on the road. Identification division. Let's capitalize everything afterwards. Can't be bothered to capitalize everything. Alright, program ID, day04 I called it. Environment division. Okay, don't need much of that. Procedure, no, yeah, data division, working storage section. And now we get to define our memory layout for the program. What do we need? We need a num, which is just to pick 6 of them. We need a valid count, just to pick 9 up to 6 digits long. Starts at 0, of course. Let's start with those. We're going to need more than that, but we can start with them. Procedure division is the next one, and I always call my first procedure 100 main, just why not. Let's perform 200 validate varying num from, what was the first number? 236491. By, strangely is the word, by 1, varying it by 1. Yeah, it's not wrong, is it? It's okay. Until num greater than 7137887. Okay. And then we're going to display valid count, and then we're going to go back. That's the basic bones. 200 validate, thank you, Emacs. Let's just add 1 to valid count in a moment, and end it. Okay, let's see if I made a mistake there. Copsy -x says build executable, -o says, and then it call it that. What is it? 04, part 04. Why isn't it like that? Did I save it? Yes, I did. Oh, day 04. Why is it called day 04? Oh, okay, well, if it is, then why not? So day 4. And if it compiles and produces an executable, let's just run it. Let's see what happens there. Valid count 477297. That may well be correct, isn't it? What is express? I think you can do this in... Is that the right syntax? No, it isn't. Maybe that's the right syntax. Yeah, 477296. Good. Shell does maths. Yay! 477296. So just because that's not inclusive here. We're sort of checking all numbers. So, for example, if the first number was 23649, the second one 23649, we'd actually be checking two numbers and not one, the first and the last. Okay, cool. So now we just have to calculate, have to program the rules. So we need an index into this number. Let's define it here. No. First thing we have to do is be able to access these numbers, because we can't index it. It's not an array. But COBOL has a nice word called redefines, which we can use here. So what we can do is we can define something called digits, and we can say this redefines num, which means it uses the same memory location as num, and we're going to sort of call this pick9 occurs 6. So now we can have a digits index. Usage index, I think that's the right way to do that. Usage index is maybe something I haven't explained, I'm not sure. That basically says make this a number which on the architecture you're running on can be used well to index into arrays and things. Rather than saying it has a certain memory layout, which we're doing here, of course, you're specifying the memory layout as being 9 digits after each other. Sorry, 6 digits after each other. 9 here just means a digit. In this case, you're saying the memory layout is whatever on this particular architecture is good for indexing into arrays. Now we can say perform varying digits index from, I can't write varying, can I? 1 by 1 until digits index greater than 6. End perform. Don't want to do this? No, I don't. I want to start by 2, because I always have to compare two numbers, don't I? I have to compare if the second number is bigger than the first number. So let's do it like that. If digits index is smaller than, then something's gone wrong, -1, and then let's write that large. What do we do then? We set some flag to invalid. Let's call the flag decreasing at the moment, and let's add a flag variable. Oops. Validation state pick9. Let's start here. 988 is searching, so we're not sure. Value 1. 88 decreasing. Value 0. 88 is valid, value 9. Let's start with those, see how far we get with them. So we set searching to true. So at the moment it's in the state of searching. And if that happens, we set decreasing to true. And if decreasing is true, so if the number in the third position, digit in the third position is smaller than the digit in the second position, then decreasing is true, that means we have to stop. So let's do that here. So it's now saying we are continuing to search through the digits until digits index is greater than 6, so we fall off the end of the number, or it is decreasing. And now we just have to make sure we set is valid to true if there is a pair. Digits index equals digits index -1, and then set is valid to true, and if and then we close this in an is valid count. Add 1 to Okay, that may well work. Let's check if it works. It looks good. No, it doesn't look good. It looks very wrong indeed. If it's valid. Strange. I wonder why this is... Did I do that correctly? Oh, that's the expression. Sorry. Okay, good. Decreasing is not defined as invalid decreasing. Actually, why invalid decreasing? Let's just say invalid. Not valid. Invalid seems to be used. Not valid. I don't like mixing this. I mean, this is a question, is valid. Not valid is a statement. Whatever. 1169. Well, we get the right answer at least. That's one we got up here. Let's check if we understand what's going on. Or better, if I understand what's going on. To start with, when we try to validate a number, we say set the state of the validation to searching. Then we go through the digits in the number, varying the digits index from 2 by 1 until you fall off the end of the number, or you know the number is not valid. And then you compare the digit at this place with the previous digit, and if it's less than the previous digit, then you set not valid to true, and if it's the same as the previous digit, then you set valid to true. I'm not sure I like this constant indexing into digits. Let's have a this and previous or something like that. Yeah, let's do this. Digit pick 9. Last digit pick 9. Let's do that because I don't like this constant indexing. Move digits index to this digit. Move digits index -1 to last digit. That's nicer, I think. This digit, last digit, and the same thing here. Digit, last digit. Okay, I think that's nicer than than indexing multiple times. I just think it looks nicer. Doesn't actually change what's going on. In some nice languages, you could just iterate through this. Well, not through a list. It would be a generator, and use a windowing function to generate through go through the generator. You could do that. Cobol doesn't allow things like that, but I think it's still fairly clear what's going on here. Good. Let's move on to the second part. Now the rules are slightly different. Now the important thing is that there really is just a pair. So for example, 1, 2, 3, 4, 4, 4 no longer meets the criteria because 4 is repeated 3 times. It's part of a larger group of 3. So that no longer meets the criteria. Interestingly, it doesn't have an example for what should happen if you have, say, 1, 2, 4, 4, 3, 4. If that's also invalid or not. Oh, now that doesn't matter, does it? Because with the rule of cannot be decreasing, that would be invalid anyway. So what I'm saying is I was wondering if a number like 124434 would be invalid or not according to this are not part of a larger group of matching digits rule. But that would be invalid anyway, because 3 has to be smaller than 4, or whatever you put between this number. The second 4 means that whatever's between is going to be bigger or less than 4, so it's going to be invalid. So we don't have to worry about that. Okay, so how to do this bit then in COBOL? I think we're just going to have a frequencies table for this. So let's have a frequencies table. 01 frequencies, which is a pick 9. It's going to be from 0 to 6, the possibilities here. Occurs 10 times, and let's have an index into it. Says index usage index. Okay, and now this is not enough. This is valid. So we now have to check to see if it's part of a large group as well. So let's make another state here. Another state flag has pair value 2. So what we're doing now is going to be setting has pair to true. And at the same time, we can also start initializing our frequencies. So let's move zeros to frequencies. That will now reduce all frequencies to 0 every time we validate a number. Okay, now we've got to move, because here we're starting digits IDX from 2, we have to remember to do this with the first number as well. So we add 1 to frequencies, and where is it? It's going to be digits 1. And now we have another problem. What I'm basically saying is digits 1, so if it starts with a 1, so if the digit is a 1, this will add, sorry, let's start with a different number. So if the first digit is a 5, let's say the first digit in the number we're validating is a 5, then this will add 1 to frequencies 5. Not a problem. Sounds okay. But what happens if the digit we're looking at is a 0? If the digit we're looking at is a 0, we have a problem. Because if the digit we're looking at is a 0, arrays in COBOL are 1 based. Of course, you can claim the digit you're looking at can't be a 0, because the smallest number, because the first digit in the starting number is a 2, and it has to increase, otherwise it will break this rule of being increasing all the same. However, that relies on the particular numbers we've been given here, and if someone had received a puzzle input with 0, 1, 2, 3, 4, 5, then that wouldn't work. So I don't like doing that. Let's instead, because arrays in COBOL are 1 based, I'm going to add 1 here. Every time I put something in frequencies, the index isn't the number, but it's number plus 1. Index isn't the digit, but it's the digit plus 1. And that will make sure that this puzzle, that this solution would also work in case someone got a list of numbers here, got 2 numbers here for the range where the first number starts with a 0. I don't know if that's possible, if the first number always starts with at least a 1. Is that written here? 6-digit number, you'd assume it always starts with at least a 1. I don't know, I think I spent enough time talking about that. I'm just going to add a 1 here because I want to. Okay, good. And then here we add 1 to frequencies, and now it's just going to be this digit plus 1. Okay, good. Now we have to check the frequencies to see if they're valid or not. So perform varying 3, I can't write, frequencies index from 1 by 1 until frequencies index greater than 10. Oh, there's an OR here as well, isn't there? But I'll do that later because I'm not sure what the OR is. And what you have to do is just check for a pair. If frequencies index equals 2, then now we can set is valid to true. And if I think this may already work. Let's see. Expecting value 18, that's in this definition. What am I doing here? Oh, yes, that's not going to work, is it? Frequencies requires 1 subscript and frequencies not defined. Okay. 37. Ah, this is my move zeros to frequencies. Yes, this isn't going to work, is it? I have to define a frequencies block. Pick 9, and there are 10 of them, and frequencies redefines frequencies block. Is that still fitting? Yes, 72, just 72 characters, it still fits. Now I can move zeros to frequencies block. So you can't move zeros to an array, sorry, I forgot about that. But you can just move zeros to a block of memory. And then there was one place where I spelled frequencies wrong. Yeah, there we are. Okay, now how are we doing? 97,266. Not well is the answer. Let's see some of the things which are getting through here. And display. Oh, sorry, not this one. Where's the is valid? Here we are. Display valid. And this is digits num. Okay, let's see what's getting through here. Maybe interesting to see. Yes, why is that getting through? Ah, I know what's going wrong. I don't clove this and an if has pair. And if there's only point in checking to see if it contains a pair if everything is increasing. If I've already worked out that it's not increasing, then there's no point checking to see if it has a pair. Okay. More. What am I doing here? Not more. Get rid of that. And now, where are we now? 757. That's the right answer. Hurrah! It works. Okay. Let's. Now we've got the right answer. Let's point out again the important things, which I think make this particularly nice in COBOL. Particularly nice makes it. There's something in COBOL syntax, in COBOL syntactic sugar, which makes this less painful than it could be. Things like move zeros to frequency block. You can reset frequencies block very quickly here. Of course, in a high-level language, you wouldn't be doing this by hand anyway. You could there are functions to get distributions inside lists. In some high-level languages, certainly in the functional languages. Functions like that tend to be part of the core language, or something you can just use out of the box, so you wouldn't be doing this by hand anyway, this here. But if you do it by hand, that's nice to have. And that only works because of this redefines verb here, which says this thing here is exactly the same memory as this thing here. It shares the same memory location. And the same thing here, this thing here shares the same memory location as this thing here. That's nice to have. Anything else which is interesting here? If you really don't know COBOL, you may find this interesting, which is a way of having various Boolean conditions according to the value, according to a certain value. In other languages, you could probably have an enum for this. So you can think of this as being how COBOL does an enum, but you do it without comparison as well. So in another language, you'd have a variable name and then a value. So you can think of Java or whatever with enums. You'd say if current state is searching or if current state is not valid. In COBOL, you can just say if is valid and if not valid, which, yeah, you may like it, you may not like it. It's something you can do. Okay, I think that's all I have to do with this exercise. Any comments, please do not hesitate, etc., etc. And maybe I'll upload something else soon. Thank you.